Hi, I'm Ryan Haug, and this is my RoboLizard project. So to start us off, I went through and had to identify the problem first, and that was already given to us in the design spec sheet. So taking that, I was able to deconstruct the problem into different steps using design decomposition. Then I was able to brainstorm various ideas on which to solve this issue. From there, I narrowed it down to a few select ideas and combine the things I like best about them, including how they stayed on the pole, two wheels, and motors. I was then able to make a CAD model. Then from that, I printed out all my test pieces because 3D printing was the easiest step to do before I started machining everything. This is a picture of how it interfaces with the shaft collar, the 3D print. Then I made the support arms out of aluminum stock. These are the drawings. Then the problem with the aluminum stock was that I drilled the holes too close together, so the heads of the screws had interference issues. So I was fed up with that, so instead I turned my efforts into making the sheet metal base. This is pictures of the sheet metal base plate, which after I designed that, I went back to the drawing board and I redesigned the support arms to be made out of wood, out of laser cut wood instead. So this is an exploded view of that new design. So that's the laser cut wood, and here's a video of the laser cutter in action. And those were when they were finished being cut out. Those are next to the metal bars. This is that all assembled. I added a little bumper switch on top and wired it all together. It sat on the pole fine, everything, but the problem is the tension. So I adjusted that. So I put up the tension by 1. So the tension you can see is in the top of the robot where there's all those holes drilled. So the problem with this part of my design was that if you notice the gripping wheel, the one with the rubber on it, appears to be slipping as it's going up the pole. So for every rotation, it's not actually advancing up the pole by its circumference. It's slightly less because it's not making contact all the way. This is because there's not enough tension on the pole, which of course I could move up the pin, but the problem with that is then the clutch activates and the clutch starts slipping. So the way I solved this was, you'll see, so there's the hack I added onto the side just to support that shaft a little bit more, and also super glued the clutch shut so that it wouldn't slip anymore. So then I stepped it up from pin 2 to pin 3, which turned out to be a sweet spot, and here's my final test. So the last part of the design process is to reflect on what you should do for your next design. So I had a couple ideas. was I should add, I really like how I use the springs. Another addition you can use is rubber bands to keep tension on that pole, because that's really important. I thought multiple drive wheels, because I only had one drive wheel. I really wish I had multiple, maybe 2 or 3, just to get more grip on that pole. The other thing is to have more than one gearbox, which kept me from doing it now, was that they were all spinning at different speeds. But then I had the idea is if you took the double gearbox and 3D printed another middle to it, so then you could separate into just 2 individual gearboxes that are both spinning at a higher rate of speed, and that would allow you to climb the pole faster. So thanks for listening to my presentation. Bye.